Okay, so we're going to talk a little bit more about finding the domain of a composite function. So let's say we have the composite function f of g of x. So step 1, find the domain of g. If it's not able to be put in, if there are x values that you can't put in for g, that's step 1. So that, you're just going to restrict it right there. Step 2, find the domain of f. Okay, now here's the tricky part. So you have to make sure g of x is in the domain for f. So these are your outputs, right? So you put in x values, you take your domain values, you put them in for g. That's what you do first. But anything you get out, that has to be able to be put into f. So it has to be part of the domain of f. Okay, so it's really confusing. You can go back and rewind this and read this part over, and I'll explain it in the example. Okay, so here we go. Well, we're doing f compose g of x, or f of g of x, just like we were saying in our rules there. So the first thing to do is look at the domain here. Well, you know that that denominator can't be 0. You can't divide by 0. So x cannot be 2 over 3. Okay? All right. Now, that's fine. I can say that. I'm taking that out of the domain. X can't be 2 over 3 because it would make the denominator 0. Now, what else do I have to make sure? I have to make sure that the output, g of x, does not equal 1. Because if it's 1, then I'm going to have 5 over 1 minus 1, and 1 minus 1 is 0, and that's going to be a problem. So I have to make sure g of x does not equal 1. So the domain here for f was, hey, x can't be 1, but it's not x that can't be 1, it's the output from g that can't be 1. So g of x cannot be 1. That means 4 over 3x minus 2 cannot be 1. So this is g of x right here. That can't be 1. All right. This I can solve. So I've got that inequality there, but I can say, hey, when does 4 over 3x minus 2, when does that equal 1? I can multiply both sides by the LCD, or I can treat it like a proportion, actually. And so these cancel, and I get 4 equals 3x minus 2. Add the 2, divide by 3. Okay, by the way, x can't be 2. Okay, because if you put in a 2, so let's look at what happens. So I'm going to go back to the original stuff here. If I find g of 2, and I'd have 4 over 3 times 2 minus 2, and then I'd have 4 over 6 minus 2, I'd have 4 over 4, and that would be 1, right? So g of 2 would be 1. But then, because I want to find f of g of x, I would have to put the 1 in here. So then I'd have f of 1, and then I'd have 5 over 1 minus 1, and then that would be a problem. Okay? So there are 2 values I can't have. I can't have x being 2/3. That's just from the get-go. I can't have x be 2/3. And I can't have x be 2. All right, now how do we write that in interval notation? Well, it might be better if I just show you on a number line how this comes. So here's 0, here's 1, here's 2. Okay, we said we can't have 2, and we can't have 2/3, right? It was 2/3? Yeah, okay. So everything else we can have. I can have all these numbers down here. I can have all these numbers in here. And I can have all these numbers up here. I just can't have 2/3, and I can't have 2. Okay, so now to write that in interval notation, it's going to be kind of long, but this is how it looks. You follow the number line left to right, negative infinity up to 2/3, but don't include the 2/3, union 2/3 to 2, union 2 to infinity. That then would be the domain for this function. So that was a little bit tricky. You can watch it again.